All right, what we're going to look at are the types of motion, and we're going to specifically look at 6 basic types and what they would look like on a distance and time graph. With this first graph, we're going to look at steady speed. So a couple things that I want you to make note of. On the y-axis, we're going to represent distance, and on the x-axis, we have time. Remember, we're not focused on our velocity, so velocity is speed in a certain direction. With this, we're just looking at the speed that the object is moving. We're going to say that this is our starting point down here at this dot. And I'm going to draw our line like this. If we look at this a little bit farther, what I want you to imagine is that you're on the straightaway of the track, and you're just walking forward at a steady speed. If you look at your graph, we're going to say over here is going to represent 5 meters. This is going to be 10. On the bottom, we're going to say this is 5 seconds, and this one is 10 seconds. If we look at where our 5 seconds is placed, and we go across, we're going to notice that we traveled 5 meters in 5 seconds. In the same way, we're going to look over here at 10 seconds, go across, and we're going to notice that we traveled 10 meters in 10 seconds. So if we look at this a little bit further, if we traveled 5 meters in 5 seconds, that comes out to being 1 meter per second. Same with up here, 10 meters in 10 seconds equals 1 meter per second. So you can see that our speed is steady. We're traveling 1 meter in 1 second, and it stays consistent across the entire 10 seconds. For the next one, we're going to look at rapid steady speed. You can see right now I have what we did on the last graph already on this one. So I have steady speed already graphed. Rapid steady speed is going to be represented with this green line. The one thing that you can notice about this green line is it's a lot steeper. And if we look at it and compared to our distance and our time on the sides, we're going to keep this at 5 meters, the top at 10, bottom at 5 seconds again, and 10 seconds. So if we go straight up from 5 seconds, on our blue line, that was our steady speed. And remember, it was 5 meters, 5 seconds. It was 1 meter per second. If we continue to go up, however, and across for our green line, which represents rapid steady speed, you're probably at about now 7 or 8 meters. So you can see in the same amount of time, 5 seconds, we're now traveling more distance. Again, it's going to be consistent, but it's faster. It's more of a rapid steady speed. The next graph we're going to look at is acceleration. And for acceleration, we want you to think of it being a measurement or a change in the object's velocity. So when you press down on the gas pedal in a car, the car surges forward faster and faster. This is acceleration, so that rapid speed up. The graph is going to look something like that. And if we break this down a little bit farther, you can see how this works. Again, keeping everything the same, 5 meters, 10 meters, 5 seconds, 10 seconds. In 5 seconds, you can see that the car did not travel very far. So in 5 seconds, we can imagine this maybe went 3 meters. However, in the next 5 seconds, we now went the rest of the way. So in the first 5 seconds, we went 3 meters. And in the second 5 seconds, we went 7 meters. We traveled a lot farther of a distance. So it simply means you go from slow, 5 seconds, did not go a lot of distance, to fast. Another 5 seconds, went a lot farther. That's acceleration. Slow to fast. For the next one with deceleration, it's the opposite of acceleration. So acceleration was going from slow to fast. Deceleration, you are now going to begin to slow down. So you're maintaining a quick speed, and now you begin to slow down. This graph is going to look like this. And again, we'll break it down so that you can see how this works. Everything the same. 5 and 10. 5 and 10. And now let's specifically look at how much they're traveling. So if you look on the side, we're going to look at the distance traveled. And let's look at just the first 5 meters. So going from 10 meters to 5 meters, it took about 2 seconds. So in 2 seconds, they were able to travel 5 meters. Okay, fairly quickly. If we look at the rest of the way, so from 5 meters now down to 0, it's going to take the rest of the way. So to travel the last 5 meters, it took about 8 seconds. So you can see the first part was fast. The object that's in motion is traveling pretty quickly, and then all of a sudden it slows down. So deceleration is going from fast to slow. This one's one of the easiest, and it's simply no movement. So for example, if we put this on the graph and look at it specifically with our measurements, 5 meters, 5 seconds, 10 seconds. If we look straight up, in 5 seconds they moved 5 meters. If we go up in 10 seconds, they still moved 5 meters. So this would just simply be if an object is stationary, or a person or a car is not moving, you would represent it with a straight line across. For the last one, we're going to look at return to start. With this, you're going to be starting at a distance. So you are farther away and coming back to the beginning. So we would say if you're starting at 10 meters away and you come back to the beginning. So similar to our deceleration one, only it's a straight line. So you can see we're moving from 10 meters back down to 0 meters in a certain period of time. So in this case, it took us 10 seconds to get back to the start, which was 10 meters away.